Alright, quiet please. Alright, question 14. Compare the graphs of three cubic functions. Which of them has a coefficient of x cubed that's negative? Once again, I keep saying this to you. I don't remember which one's which. I always go to my calculator and I make up a hypothetical x cubed one. So I just go, no bother, x cubed minus, I don't know, 2x. I stop there and I just go, no bother. I start at, I don't know, minus 10 to plus 10. And then I figure out what direction it's going up in. Is it starting low and coming up, or is it starting high and coming down? Anybody? Alright, so I just put, so for me, this one is a positive x cubed, and that one is a negative x cubed, and this one is a positive x cubed. So which one is it? B. Which graph has only one real root? Means it only crosses the x-axis at one point. C. Which graph is positive and decreasing? What does positive and decreasing mean? Yeah, positive is above the x-axis, and decreasing means on its way down. So which one does that in between 1 and 2.4? So there's 1 and that one's already on its way back up again, isn't it? 1 and 2.4? That's it there, isn't it? It becomes negative. It's still on its way down, but it becomes negative. Alright, so what do you reckon? B? Okay. And finally, which graph is negative and decreasing all the time after 2.4? Negative and decreasing. Oh yeah, still B, isn't it? Because it's negative and it's going down for... How do we know it's not going to turn again? How do we know it's not going to go, woo? Why? There's already been 2 turning points, isn't there? And there can't be another one. Happy days, alright? So that is also B. The answer was B for 3 out of 4 of them. Very uneventful. Alright. Let's pair off the graphs here and see which ones we think are which. Okay, let's go for the easy stuff first. One of them's a straight line. So which one's that? Huh? That's F, isn't it? Alright, done. Alright, Brown. You alright? Thought you were asleep. Now, Christian Brown's asleep. Alright, next one. What shape is this one? U or N? U. If you solve it quickly equal to 0, what can you say? X equals 0, which is the point 0, 0. And then? So what one would that be? E. Happy days. Alright, let's keep going. So that's E done. What about this one here? What happens when we put y equal to 0? 0 equals 1 minus x by 1 plus x, which means x equals minus 1 and x equals, which would be in A. Equal intercepts left and right. Okay. Alrighty. What do you reckon about this one here? What can you take out? Alright, so do 0 equals x into x minus 1. So what are the two intercepts? 0, 0 and? So what does that make that one? B. Okay, we're pretty much nearly done now. What else is there? Positive x cubed, so what does that mean? On its way up, followed by its way down, so that's C. And the last one is D. Yes? This one here? Yeah, I could do that where I take out x squared into, what's it, x minus 1? Yeah? Here? Yeah, I could do that as well. For D, I could take out x. I could get 0 equals x into 9 minus x squared. X equals 0, x equals plus 3, or x equals minus 3. And you can see that's plus 3, so minus 3, plus 3, and the 0 in the middle. Is that right? Same deal. Alright, 15 done. Alright, I'm just sticking with the diagram questions because they're really quick to get done with the projector. Alright, using your graph, estimate F3. Which one's F3? What does F3 mean? Input a 3. So what's the answer? Minus 27. You could also cheat but just replacing the x with. You could check your answer, couldn't you? Okay. What do you reckon about the maximum turning points? Sub in 1 and what happens? Minus 1. What happens when you do that? What do you get? Plus 5. We already knew that though, didn't we? That was unnecessary. 1, 5. Okay. What about the next question? Where does the y value equal minus 20? When does the y value equal minus 20? Where does that happen? What? Like minus 2.9 or something? What about here? 1.8, 1.9. And what about here? 4. 3 points. That's loud, isn't it? Try and close that over for a sec. Four minus 2.8, and what's the other one? What do you say? 1.8, 1.9 ish. Right. Find the range of values for which it's decreasing. What does that mean? Let's go and go back a few steps here. Get rid of all those lines. So decreasing, what do you reckon? Where's it decreasing? What are the values there then? In between? In between minus 1 and 3. Minus 1 less than or equal to x less than or equal to 3. Is that alright? Explain why the equation fx equals 10 only has one root. That means the output equals 10. So draw a horizontal line going across at y equals 10. And why does it only have one root? Only intercepts the graph once. So this point here only has, there's only one x value that results in a y value of 10. Does that make sense? Explain why y equals minus 10 has 3 roots. Anybody? Yeah, intercepts the graph 3 times. I think Miss Sweeney's here now. Are you here now? No, you are. Alright guys, if f of x equals k has 3 real roots, estimate the range of values for k. What are all the answers that you definitely have 3 answers for? So let's what we're going to do is I'm going to move these lines until we have 3 definite answers. Okay? I'm not going to move the full graph, I'm going to move the lines, okay? Now, come here. Alright, how many answers does this horizontal line have? 1, 1, 1, 1, 1. Technically 2. Anything below that line? 3. So any k value smaller than 5. Keep going. We still have 3, 3, 3, 3, 3. And then, what's that, minus 27? But then, after that, that's only 2. So it has to be above minus 27, doesn't it? So k bigger than minus 27, but smaller than 5 will result that. Alright, yeah, let's take your break. Now, alright guys, use the information given below to find the equation of this function. Alright, first question for you. Alright guys. Use the information given to find the equation of the function. First thing I'm going to ask you is it positive x cubed or a negative x cubed? It's on its way down at the start, isn't it? So first thing I'm thinking is negative x cubed. Next thing we're going to look at is what you reckon about where it crosses. So to me it touches the axis, so what does that mean? X equals 2 twice. Crosses once here, what's that? X equals minus 1. So I think the graph is this. I think it's you have to move it over to your side then, don't you? So if x equals minus 1, we're talking about x plus 1. And if x equals 2, we're talking about x minus 2 and then x minus 2. Now, what's wrong with the graph as I currently have it? Can anybody tell me? Would that be a plus x cubed or a minus x cubed? So what should I put on the outside to rectify that? Now, I'm going to be a bit lazy here, and what I'm going to do is I'm going to put it into my calculator to see if the points match the ones on the board. Okay, so I'll do that really quickly. We hope. Here, did I rub that out? There we go. Alright, so let's do this. We're going to go for minus 1. Now, it's not guaranteed to be a minus 1, is it? Could be a minus 2, could be a minus 4, I don't know yet. Okay, but I'll just start off with minus 1. Okay, and then we got x minus 2. X minus 2 squared, technically, isn't it? Put it in, and then go for, yeah, 10 to 0 will work for me. Keep going down. And then, what do we see? 0 minus 4. Is it 0 minus 4? 0 minus 2. Interesting. Okay, let's try another one. Anybody see? Let's keep going for a second. 1 minus 2. That's clearly 1 minus 1. Does everybody see that? So what adjustment do I have to make? My one is twice as large, if you get what I'm saying. So what's the adjustment I have to make? Yeah, I'm going to half it, haven't I? Is that alright? Halved it, because halving it works. And then just go back to the beginning and just put it over 2 instead. Sorry, just do this. Nope, don't do that. Whatever I just did, do not do that. Oh, distress. Alright, I'm going to be lazy, just go on 0.5 it. Is that alright? If I was the whole fraction nonsense. Does it work this time? Let's see if it matches up. 0 minus 2, yeah. 1 minus 1, 2, 0, and 3 minus 2. Perfect. We nailed it. That's the equation right there. Is that alright? You can multiply it out if you want. Explain why this function is not injective. What does injective mean again? 1 is to 1, isn't it? So a line is injective. Okay? Does the domain have to be busy for injective? No. Either way, the horizontal line test says that there's three inputs for 1 output, which means it's not injective. Is the function surjective in the range 0 to 2 for the y values? Now let's highlight 0 to 2 for us here, okay? 0 to 2. 0 to 2. There's 2. And that's all the way to 0. Is that surjective? Yeah. What do you say? When it equals 0. Surjective means every output has an input, at least one input. So in the yellow and the horizontal line has to hit every part at least once. So to me that is surjective. Is that okay? That is surjective. Explain why the function is not bijective. Well, it's not injective to begin with. So bijective would be perfect 1 to 1, isn't it? Like a straight line. Every input only has one output. Every y value has an x value. The codomain is busy. Use calculus to show that the stationary points occur here. Okay, I'm going to have to use calculus. Alright, so this is a pain. So here's what I'm going to have to do. I'm going to have to multiply all this out, which is not going to be fun. So y equals minus a half into x plus 1, and that's going to be x squared minus 4x, what's it, plus 4, yeah? Then I'm going to multiply this out, and I'm going to get minus a half into alright, next thing is you multiply this out and you get x cubed minus 4x squared plus 4x x squared, what's it, minus 4x plus 4. Alright, what does all that whittle down to then? Anybody? 1x cubed, isn't it? Oh god. Yeah, what? Apparently I can't write anymore, which is interesting. What did you say, minus what? 3x squared, yeah. No x's, is there? And then just plus 4. Alright. Anybody remember how to differentiate? Alright. Just ignore the half. Just ignore that part. And just concentrate on differentiating this part here. Okay? Or you could just multiply in by the minus a half. What happens when you multiply in by the minus a half? Comes and then what's it? Minus 2. Right, now differentiate it anyway. Right, go on. What happens when you differentiate it? Yeah. Plus 3x. Is that it? And equals 0. Why does it equal 0? What's 5 over 2? I'm multiplying the 3 over 2 by 2. 2 multiplies by 3 over 2. It's alright. Now, what are the two x values at play then? I think we multiply across by 2, will we? And we get... Okay, now what? This is awful. Why am I doing this? I don't know how to do this. 0 and 2. Is that what was expected to happen? 0 and 2. How do I get the y values? Sub it back into the original function, and you'll get 2, 0 and 0 minus 2. Okay. I felt like I aged badly doing that one. Alright, you guys have a look at 23. Alrighty.
Good afternoon, all class. Just one further few announcements.
So lads, we talked about the maximum, which is this one here. We talked about a min, which is this one here. And sometimes there's what's called a saddle point, where it sort of flattens out just momentarily before it's still on its way down. So this is not a saddle point or a point of inflection, and you usually get it when the second derivative equals 0. Is that alright? Now, find the range of functions for which the value of x for which y equals 4x cubed minus 3x to the power 4 is increasing or decreasing. Interesting. Alright, there's a graph of it. I just drew it out. Okay? And we can see that it's increasing where? I think it encounters a point of inflection here, doesn't it? What does that mean? 4 seconds it's going straight across, isn't it? And then it's still increasing. And then what point is this? Which is the max. And then all the way down it's on its, the blue section, it's decreasing. Would everybody be cool with that? Alright, now how do we know that without actually sort of drawing it? So what we might want to do is we might want to throw it into the calculator and just have a quick look at what's going on, alright? Now usually we go from minus 10 to plus 10 just to get a viewpoint of what's going on. Okay, and you can see the numbers are astronomically big, aren't they? Doesn't really tell me much. So I might want to go from minus 2, I don't know, up to plus 2. And this time, what should I do with the gap? A gap of 0.1 maybe? Would that be alright, or is it allowed? Range errors, what does that mean? So maybe 0.2. I didn't get a range error this time. So it's basically matching what we're drawing there, doesn't it? It's on its way up for 1.4, minus 1.2, minus 1, 0.8, 0.6, 0.4, and then it goes to 0, 0, and then it raises all the way up to 1, 1, and then straight after 1, 1 it's on its way down. So it's safe to say we could graph that out quite quickly, couldn't we? Now, let's find when it's increasing. So you have to find when the slope, you want to find when the slope is bigger than 0. How'd you do that? First derivative. And what happens when you do the first derivative? 12x squared minus 12x cubed. And you'd like that to be bigger than 0. Okay. So, what can we take out here? Take out x squared. And what's left over? That's perfect. X squared is always what? Oh, thanks Mick. Best signing of the summer. Bigger than Ronaldo. Alright. Go with that. Now, bigger than 0 means it's what? Increasing, isn't it? So, why is the x squared, why does the x squared not matter? Always positive. Or 0 or positive. Okay? What determines if it's positive or negative? If x is bigger than 1, what does that mean? Overall it's negative. If x is smaller than 0 or smaller than 1, overall it's positive. And that's what the graph tells us, isn't it? So anything smaller than 1, it's increasing. And anything bigger than 1, it's decreasing. Awesome. Find its stationary points. How do you find the stationary points? Second derivative equals 0. We already have the first derivative equals 0. We get x equals 1, don't we? And then we find the other point, which will be 1, 1. And how do you find the stationary point? One more time. Second derivative equals 0 for the stationary point. 24x minus, what's it? Is that right? Oh, sorry, 26 x squared equals 0. Is that correct? Alright. Oh, the saddle point's here, is it? It's halfway in between. Figure that out now. Alright, so what do we get then? Factorize out x and we get? And now what's the other one? Sorry guys, finish it off now. Let me wrap this up. That's x equals 0 for one of the saddle points. Do we agree with that one? And then what's the other one? 36x equals 24 and x will equal? Yeah. There's the second one there, wasn't it? There's two of them. There you go, done. Now we never speak of this class again. Enjoy that, Christian.